Hello, Java.IL. Very excited to be here. Very excited to talk about authorization. I had my fair share of experience in that subject matter. Just want to thank the organizers for a great event. So let's get started. What I'm going to talk about today is how to build, implement authorization into your own projects. Okay, it's something that every application needs. So there's good ways to go about this. There's less good ways to go about this. So I'm just gonna explain the best practices. I'm gonna talk about the emerging open source ecosystem. So there's plenty of open source projects that you can use when you implement on your own. Okay, so it's best to go with what the community finds to be more promising when you are tackling such a big project. So a bit about myself. I'm the founder at Permit.io. Previously, I was a software engineer at Facebook. So this is where most of my Java experience comes from. I used to work on a huge service in Java. It's called the Unity system. That's how Facebook serves the app to emerging markets. Everything is server-side. So I used to do a lot of Java. Yeah, it's been a nice experience overall. So yeah, let's jump right in, okay? So first of all, let's explain the terms a bit, okay? Because a lot of people are confused sometimes between authentication and authorization, okay? So authentication handles who you are, okay? So every time you use Face ID on your phone, your identity is verified, or every time you enter your user password at a login form, log in with Facebook, Google, this is authentication. It means I want to check that you are who you claim you are, okay? This process typically culminates in you getting a digital passport called a JSON Web Token. That's the accepted standard. And then the application knows, based on this cryptographically signed passport, that you are who you are, okay? And then the application can do stuff with this JSON Web Token. Even before the authentication system, there's an identity management system typically. So solutions that you know are probably Okta or Azure Active Directory that seeds all these identities to the authentication system. So in order to manage a centralized database, probably if you're working in a large company, you don't have to re-log into every system. You have single sign-on. That's basically based on the identity management systems. Authentication systems are stuff like Auth0, one login you may implement on your own with super tokens. And there's authorization. So authorization handles with the question, what can you do in your app? Okay, so if I'm Asaf, what am I allowed to do in the IT system app? What am I allowed to do in the financing app? Okay, so my permissions differ based on the app that I'm trying to access. It's not just who I am within the organization. It's what system I'm trying to access, okay? So authorization, what are you allowed to do? So there are emerging solutions in the market for that as well, but if you want to implement on your own, there's a bunch of open source projects that are able to help you do it quicker and with less implementation mistakes, basically. So authentication, who are you? Authorization, what are you allowed to do within my system? Okay. And authorization exists in many levels, okay? So it's something that we are enforcing across the stack. So first, there's physical authorization. If you have a key ID to your office, right, it may open the office. If it's a huge corporate, it may open several doors and others don't. Okay, so there's physical access. There is network access. So implementing firewalls, VPN, zero trust solutions. This handles the question, what IPs can talk to what IPs on what ports. So that's on the network access. There's the infrastructure level. So show of hands, anybody here working with Kubernetes? Yeah, so if anybody knows what admission controls are? Yeah, so typically, if you work in a system like Kubernetes, you can inject a lot of code into the system with just a git commit, typically, if you're working infrastructure as code. And a lot of the time you ask, is this container allowed to run? Okay, is this deploy even safe? Okay, so there's a lot of rules about what gets to be deployed and what not. And for that, you have infrastructure level authorization. Most people know Amazon IAM or solutions like that are authorization level, infrastructure level authorization. And finally, there's the application level authorization. Okay, so which entities can interact with which features, okay? If I'm a user within the app, am I an admin? Can I access these data sets, okay, these rows in the database? Am I only allowed to access objects that I'm the owner of? So think about Google Drive. Okay, so I'm only allowed to access documents that I created or belong to my organization, or if somebody invited me to a Google Docs document, I'll be able to access that, otherwise I won't. So that's application level authorization. And we'll focus on the application level. So you typically see that screen in almost every application you use. So I took that from Linear. It's a ticketing system. It's like Jira, just better. So I highly recommend Linear. But I just took this user management screen that shows you what users are allowed to access the app and with what roles. Okay, so this exists in a lot of applications that you see. And the question is how to build it correctly. Okay, so it might look easy, right? Let's just create a table in our database and just store all the roles that we want, all the permissions that we want, have some kind of like huge dictionary in our RAM that says, okay, this role is allowed to access this permission, and that's it. But authorization is it's deceiving, okay? It looks deceptively easy until you have to refactor it 5 times, okay? And typically new demands will come, and you will just say, oh, I didn't think about this, so now I have to refactor everything again. And this typically happens because authorization is an infra that you need for your app. It's something that is a requirement from your systems, but it's typically not the core value proposition of your company. So it's something you have to do, but you just want to keep going and working on your next cool feature, right? So a lot of the time, you'll do the minimum that you need and then continue. And this creates a lot of refactoring and a lot of pain. So I'm not saying you need to become an authorization company and just implement everything up front. It doesn't work. And we all like our MVPs. I'm saying that if you are building this minimum that you need, you can do it in a way that won't be so painful to refactor. Okay, so yeah, it's a trap. It's not that easy, and I'm going to talk about the challenges today. So why are permissions so difficult? There's 3 categories of the main reasons it's so difficult. So there's infrastructure challenges, there's modeling challenges, and there's compliance challenges. Okay, so let's start with infrastructure challenges. Today, applications are much more complicated than they used to be, okay? We used to have monolith applications, a huge service, one database, and we'll just iterate on that service. We'll have that roles table in the database, we'll have that permission table in the database, and everything used to work. And every system would have its own typically community brewed best practice system for authorization. So if I work on Python Django, I would have Django auth or Django admin, whatever, a GitHub project that I could download, and it's just a permission infra within my app because I have just one service. Or if I worked on Java Spring Boot, I have another library for that. So a library would typically solve my issues. But now we have microservices. So, and typically they're not even the same language. So I could have some of my services in Java, some of them are in Node.js, and I need one way to enforce authorization across my systems. Okay, because if I will duplicate the logic across services, somebody from security, typically under the CIS organization, would come and say, no. This creates drift. This will create security incidents. Don't do that. So centralizing the decision architecture creates difficulties. So now you need one microservice for authorization that enforces it across the stack. And centralized .z is more difficult. You need to think about data challenges. So you need to stream all the contextual data that you need to enforce decisions to one place. Okay, and it is authorization data is application data. Sometimes you want to know what account a user belongs to. That's also application data, and that also data that contributes to authorization. And sometimes you have data from third-party services. So what if I'm wanting to enforce authorization based on is the user paying, right? That data exists typically on Stripe or Chargeify, whatever you use. So you want to stream the data into your decision system, your microservice, and then you want all the data in one place, and based on that enforce access. But that data also needs to be updated in real time because it changes based on user events. So that's a challenge. Finally, there's performance requirements from that service, okay? So think about a service that you need to ping in every request to your application, every request to your backend, and that kind of service is critical to your SLA, okay? If it's down, your application is down, so it needs to be really stable. It needs to perform with almost zero latency, okay? So like a request to your database or to Redis, whatever. And thank you. And you also want to make sure that it has redundancies as well. So building that kind of service is difficult. Second, there's modeling challenges. So show of hands, who knows what role-based access control is? Okay, about half, cool. So a lot of you know what role-based access control is and are implementing that into your systems. Who got, by the way, to implement role-based access control? Anyone? Yeah, did you enjoy it? I feel your pain. And so a lot of people know what role-based access control is, know what permissions are, but your application will grow quickly. Hopefully, you will have more users, more demands along the way, and you'll have to build more complex systems, okay? So if you want to enforce access based on if the user is paying or based on ownership, if I'm the owner of the document, I want to enforce access. Then it becomes more complicated. You need maybe role-based access control with ownership. It's a different variant of RBAC, okay? Or you want attribute-based access control, which means I am getting access based on the user attributes. You might have complex relationships and you need relationship-based access control. So if well, everybody here are using GitHub, right? Within GitHub, your access to objects is determined based on a graph. So the simplest question, can I close this issue, has multiple answers, okay? So if I'm the one that opened it, almost every time I can close it. But let's say I didn't open the issue, I just go into a random project in GitHub. Can I close that issue? Typically the answer is no. You need to either have a direct role into that repository. So I can do it based on having a role to the repository that contains the issue. So that's 2 hops in the graphs. But I might have a role to the organization that is the owner of the repo, and that's 3 hops in the graph. And modeling that kind of system is complicated. It's not impossible, but you need to be aware that it's complicated so that you won't make the mistake in modeling it when you first set out to implement it. So modeling is a challenge. And finally, there's more compliance demands than ever. Okay, so we all like our privacy, and that's a good thing. And we want companies to be diligent about keeping that information safe. And we want to make sure only authorized people access our private records. But to the person implementing all of these requirements, it's a pain. So when you build that kind of authorization system, you want to include into that system auditing. So who accessed what? That's requirement number 1. You can't even start implementing something like this without auditing. You have all these compliance demands. You have SOC 2, you have HIPAA, you have the CCNA. And I know the European Union is now considering a new standard. Don't know if you heard about this, but I heard it's going to be a pain for all of us. It's important, but it's a pain. So you'll need auditing, you'll need checks and balances. So who is allowed to to change the authorization system itself? So think about off-Z for off-Z. This kind of problem becomes recursive. Okay, so who's gonna watch the watchers, right? So checks and balances is a challenge. Approval flows sometimes is a challenge. So you want to implement checks and balances based on approval flows. So I need at least like 2 people to sign off every commit to the authorization system, right? So I need to implement that. So and many more challenges about compliance. So it's no wonder that access control is the top issue in the OWASP top 10. For those of you who doesn't know, OWASP is an organization that ranks the top cybersecurity threats to apps. And they just like did a survey of apps, and they tested all the apps in the survey, and 94% of them had access control bugs. Okay, so hackers sometimes don't even need to hack your application. They just need to walk within the cracks of the permission system and basically just jump in. So access control is broken, and you want to make sure when you implement it, it's not. It's less hassle for your company. So let's talk about the common pitfalls first, and then we'll talk about the best practices. So the first pitfall is coupling application logic and authorization logic. So this is a piece of code that checks certain permission within an application. So this is authorization logic ingrained into an application. So first we discussed it doesn't work because of drift, right? But also, can anyone even read this and understand what I'm trying to check? So if I'm hiding the function name, and I kid you not, I took this example from an actual place. I obviously changed a bit of the details, but this is a real example of some application in the wild. So don't do that, okay? Don't don't hard code any rules into your application. It doesn't work. It's gonna break. It breaks down with microservices, as we discussed. So if you had a monolith, this might work, right? But the second you have more than one microservice, you have to copy these rules into the other microservice and keep them in sync. And if it's different repos, it's a hassle, and it creates drift, and drift creates security incidents. So don't do that. Instead of doing that, you want to do this. Okay, so if you implement your own permit system, you just want to have declarative checks in your code. Your developers, let's say you're a application platform engineer and you build a platform to your own developers within the company, or if you're a really small team, you're building this for everyone in your team. You want all authorization checks to be declarative within the application. So every authorization question has three main components. Who is trying to access? So that's the user or even a machine if it's an API key. Okay, so who is trying to do the access? What he's trying to do. So the action that you try to do. So in this example, create. And on what resource is the action attempted on, right? So for example, a document. Okay, so is this user allowed to create a document? Notice that in this example, there are no roles. There are no attributes. It doesn't concern the developer that's trying to do the access, right? It's just declarative. That's what I'm trying to do, and let the authorization system deal with that. So that's the best practice. And if you have this, you typically just need a very lean SDK with all your microservices, and you have to implement this in one place. And your authorization microservice needs to be based on a policy agent, and I'll get to that, but that's the best practice. So please don't hard code permission rules into your application. It's gonna end badly. So nobody will come yelling at you, but you'll probably have a security incident. So that's one of the top reasons there are security incidents with authorization systems. The second common mistake is mixing up authentication and authorization. So just a quick check. Who doesn't know what JSON Web Tokens are? Who doesn't know? Okay, so at least one. So I'll explain. So JSON Web Tokens, you can think about it like a passport, right? If I'm going to the border control, they need to verify that I am who I am, and that's way I'm allowed to get into the country or out of the country. Okay, so how can I trust a passport? Typically, a government, a trusted entity, signs on that and embed a bunch of signs into that document so that the person checking that can verify it's authentic, okay? So we all know what passports are. JSON Web Tokens are digital passports. The way they are enforced is with public key cryptography. So somebody who is the trusted entity signs on that with a private cryptographic key on a token that looks like a JSON document, okay? And it attaches the digital signature into that document. And then when somebody else gets to look at that document, they actually can verify that the trusted entity actually signed on it because everybody knows the public key. So I can verify that this document was signed with the private key that belongs to a public key. So JSON Web Tokens are digital passports. They are used in almost every application today as the bridge between the authentication system and the authorization system. And the typical mistake is that a lot of companies are just injecting the role itself of the user into the JSON Web Token. Okay, but that breaks down quickly because think about a typical authentication into the app. You are doing the login, you entered user passport, you got your JSON Web Token, now you're within the app. Now I cannot actually, because it's encoded into the JSON Web Token, I cannot actually change your permissions or your access until your next login because you have a session. That session is not expired so quickly. Typically you get, I don't know, a JSON Web Token for 2 weeks, 1 week, depends on the application. And now your access is static. So think about the most basic interaction with access control. You invite somebody to Google Drive to a document. You expect access to change immediately once you did that. So if you encode access into your JSON Web Tokens, you won't be able to. You have to force the user to relog out or wait until the next login for access to take place. So obviously it's not a good idea. But another idea that I see pops up in the wild is, no, I won't like just encode the role. I'm just gonna, I don't know, encode a lot of like personal claims into that. So it's like the same thing, but a bit different. But JSON Web Tokens are also limited in storage. So since they are typically passed in HTTP headers have a certain limit on their size. So you cannot have a huge JSON Web Token. It doesn't work. So what you want to do is take the JSON Web Token, put all your organizational claims into that. So who is a person, what department they belong to in the organization, okay? And like typical claims that are related to who the person is, okay? So this is Asaf from the marketing department, and he's been at the company for like since July 2020, right? This won't change. So because you cannot change who you are. So think about a passport. And then you can take this JSON Web Token data and translate it per application. So the head of IT should probably be able to access the IT apps as admin, but not the financial apps or, I don't know, the salaries application. That's probably something that people from HR should access. So JOTs are for organizational data. And the authorization data should be kept like within your authorization service. And there is typically some form of logic to take the claims and translate them into a role, but that should happen within the authorization service, not encoded into the JOT. And finally, thinking you solve this once and for all, not planning ahead. So what's the problem? We'll just do admin, not admin, okay? So you will get new demands for authorization every, I don't know, 3 to 6 months, and it's constantly incoming, and you'll have to change your system. So let's take a real example how it can change. So first, we are a very, very, very early stage company, or we are a company that doesn't care about authorization that much. Let's do admin, not admin, right? It's the easiest thing. I'll just keep one flag in the database per user, and easy, right? Checking permissions. And it's gonna work for about 2 weeks. And then somebody from your product team, some customer would say, you know, admin is fine, but I want an editor role. So just edit, but don't like enforce, I don't know, don't invite users. So now I have 2 roles. So please don't do that, okay? It's gonna break really quickly. And every time you'll need to change something, you'll have to ask a developer to do so. So I've seen a lot of frustrated product people saying, I want to have this feature and I want to have it to sell to this enterprise customer, but now R&D saying that this next refactor is gonna take a month, right? And it's gonna compromise the deal. So don't do that, okay? You'll at minimum need role-based access control, which typically looks like this. I have an editor role. The editor role can access certain resources within my application. So if I'm a to-do application, this editor role can create tasks, update, list, retrieve, whatever, but cannot delete tasks. And a role is coupled to permissions. So a permission is typically compromised from the resource that you're trying to access and what level of access. So resource and action. And with role-based access control, you have 2 mappings. So you have roles to permissions. Actually, I did that on reverse here, but it's user to role to permissions. So it's roles mapped to permissions, and users are mapped to roles, and that is flexible because now if you change your role within the organization, so roles typically are job functions. Now I'm promoted, or I move to a different department, or I switch from being a software developer to being a DevOps engineer. Now my access is changed based on the role that I have within the organization. And that can typically hold for a bit more than 2 weeks. A lot of companies can last years with this. Okay, so typically that's the minimum that you need to make sure that you can coast a bit more until the next refactor. Okay, and if you implement this with policy agents, it should be pretty easy. Eventually, you'll get to a point that you need more fine-grained access. So what if I want to gate access based on the user location? So only US users or only EU employees can access something, or based on the device. I want to discriminate, and only Android users can access this feature, and not others. Is the user paying? So all these attributes are not the typically role of the user, but you want to enforce access based on that. So you need to build an attribute-based access control system, and that will take you some time. So some customer that we are advising to that use their open source, it took them around 2 months to implement. If they wouldn't use our open source, I would say 6 months at least to implement. I'll explain why in a second. But you won't start with this, okay? If you need attribute-based access control, it's because your customers are sophisticated and they will demand this. And typically, if you sell to enterprise, and that will require some effort from R&D. And the jump from role-based access control to attribute-based access control can be difficult. If you use policy agents, less difficult. So what you want to do is to plan for your next refactor by following the best practices. So let's talk about the 5 best practices. So the first one is you want to decouple policy and code. I know that I'm stressing this at least 5 times, but please do. Have one service for policy, and you typically want policy as code, which I'll talk in a second. You want to make sure your system responds to events in real time. So if a user asks to change access, somebody invited me into the application through email invites, or I don't know, I want to make sure that I expire some API key or rotate an API key if it's exposed. I want to respond immediately to that requirement, okay? So you want to have some form of event sourcing or event ingress in your system so that everything is processed immediately. So no polling, please. Polling doesn't work. The next best practice that we recommend is GitOps for policy. I'll explain in a second what GitOps is to those of you who doesn't know, but the idea is that all policy changes are code changes and they go through Git, like any application change. So it can be audited and code reviewed and all of that. The next best practice is don't reinvent the wheel. There's plenty of open source to be based upon, and then you can shorten the time to implement. And finally, you don't want to forget UIs, okay? You need interfaces for customers. So a lot of the time the requirement is I want my customers to manage their access on their own, right? So I want them to have this screen that I've shown before of user management where they can allow to assign roles themselves, invite other people through email. I don't want every access decision to go through R&D, so I want interfaces. So that's the 5 best practices. Let's go over them quickly. So first, decoupling policy and code, okay? I recommend a policy agent. So what a policy agent is, it's a service, okay? Show of hands, who knows what open policy agent is? Anyone? Okay, that's a first for me, so I'll explain. So OPA is an emerging CNCF project. Not emerging, it's pretty well adopted. So all of you knows what Kubernetes is, right? So there's the CNCF, they have all of these cloud native projects. So there's about 5 projects that are graduated from the CNCF. So are on the same maturity level as Kubernetes, and OPA, Open Policy Agent, is one of them. So even things like Envoy, or I'm not sure about Envoy, but like a lot of the projects that you know did not reach this kind of maturity level. So very, very few projects reach that level. And that's because OPA is almost the gold standard for policy agents. And it was built originally for Kubernetes. So people wanted to enforce through a policy language what containers can actually be accepted into the cluster, so admission controls. And OPA started from there. They have a policy language called Rego. So it's a very simple language. You can look at it like this. It's similar to JSON. And you can express rules like the rule that you see here, that some users are allowed to put pets, right, into the, like allowed to call the put pets API. So very easy to learn, very simple rules. And if you use OPA, you can have all your policy code separate from your application and expressed in Rego, even in a separate repository, and iterate on that separately. Okay, so OPA needs a policy and it needs data. So data is, think about the contextual data. So all the user roles within the application, the roles of all the users, what permissions are granted to what roles, I don't know, all the keys that are used to check API keys, all of that. That's your world picture. That's what the policy needs to do the enforcement. And that is typically expressed in JSON with OPA. So OPA gets it gets policy and data, and then it can answer authorization queries. It gets an input, a question, is this user allowed to do that? And it will give an answer. And it always speaks JSON. So you give it every JSON that you want as a question, and you'll get a JSON answer. And you can express everything in JSON and in code. So that's the way it works. So that's how it looks like. Okay, so here's a policy. The policy is very simple. It's an RBAC policy. Okay, so user is granted, basically if one of the user roles contains a grant, RBAC, role-based access control, and it has a special flair for admin roles. So it has a rule, if user is admin, it's allowed to do everything. Right, so if it has this role, it doesn't matter if the role has a permission or not. Like the admin is like a special role that does not need to check permissions. So that's the policy here. And this is how you would express the data with OPA. So you can see a list of all the user roles in the system. And this way you don't have to pre-encode a role into the system. It's just JSON that always changes, right? So I want to add a new role, I just change a JSON. And all the grants for that role, all the permissions. So a customer role can read the resource dog, right? Or read the resource cat, whatever. So that's the data. So once you load these two into OPA, you can ask questions. So there's the input and the output. The input is the question. So can Alice read a resource of type dog with the ID 123? Okay, so not the greatest example. I just took it from the OPA playground. And you'll get typically an output in JSON. So allowed because user is admin. So that's how you work with OPA. So OPA is well adopted. You can trust it. It's the same level as Kubernetes. It's really fast. So you'll typically get less than 1 millisecond latency within a question. So once you load everything into OPA, it's like calling a database or a Redis. Everything in OPA is kept in memory, so it's RAM-based. It's responding very quickly. And the problem with OPA is that it doesn't have any administration capabilities. So it's an agent. You would typically deploy it as a sidecar to all of your services, but there's not one single control plane solution that can manage a fleet of OPAs. If you're a large organization, that can be an issue. So Why it's an issue? Think about if I change the user role. So Bob was an employee before, and now I decided that Bob is an admin. So that is a change to the world picture. And if I'm doing it with event sourcing, I would typically send an event once the user invites Bob, right? And then it would go into a queue or whatever, and then a service would consume that event and change the data. And this happens all the time. So data changes based on user events. There's a lot of data. If you have a big app, you typically have thousands of users, and you don't want every time to change all of that data. You just want to change a diff, right? And sometimes that data doesn't come from you. So it comes from Stripe. Stripe sends a webhook. This user is now paying, so change the user's access, right? So the challenge of managing OPA, synchronizing data, managing real-time with OPA, is difficult. So a few years ago, Netflix did a talk how they build their solution based on OPA. So they had to build a control plane for OPA. They did it in-house. They didn't open source it. Okay, how they manage all their agents. So every time you access Netflix, it's actually checked with OPA. Okay, and they built their own solution, and they weren't good citizens. They didn't open source it. So we did. So we actually built the same thing as open source. We call it OPAL. Okay, so OPAL is the administration layer for OPA. And OPAL is built in a way that every policy agent in the market that will eventually be adopted as OPA, we can just add it. It's decoupled from the policy agent itself, so can easily be extended to more agents. So OPAL is an administration layer that you can use to manage a fleet of OPAs and send updates in real time through the system. So you typically have a control plane, which is the OPAL server. The OPAL server listens on Git to the policy changes, and also it can respond to webhooks. And once it gets any change, it sends these changes through WebSockets to the OPAL client. And each OPAL client manages one OPA agent, okay? And it acts as a listener. It subscribes to all the relevant policy changes that you need with a pub/sub mechanism. And then every time there's a change, we just submit it through WebSockets. So it responds really quickly, typically within milliseconds. And it knows how to handle a lot of agents. It knows how to handle the situation where some services need some data and other services needs other data. It has a pub/sub mechanism. And it's also extensible, so you can write plugins to OPAL, and you can teach the OPAL client how to fetch data from other services like Stripe or MongoDB or whatever. So if you have a service that contains all of this contextual data, you can teach OPAL how to read that without exposing your OPAL server to that information. Okay, so it's easily extensible. So it's open source, it's Apache 2, it's client-server architecture, policy is managed in Git. I'll explain why GitOps is important in a second. It has real-time updates through WebSockets. It's extensible with a plugin system, and it's battle-tested. So fun fact, Tesla is using this in production. The story is that they are doing a fleet management solution for their cars. So if Tesla is selling a fleet of Teslas to a company, you would have a calendar application that you can book a Tesla for tomorrow at 8. And that Tesla would only open for you. And that is implemented with OPAL, so it's a cool story. So the third best practice is adopting GitOps as a policy workflow. So what is GitOps? GitOps is a framework for controlling everything through Git. So all of the versions are controlled in Git. So for example, if you do GitOps for infrastructure, every deploy needs to be a Git commit. And this is good because Git commits are auditable. You can know who made the change. And it's rollback. It enables rollback easily, and you can see the entire history. So every commit is a version of the application. So GitOps is great for infrastructure as code, and it's also great for policy as code. So if you use OPAL, you can have GitOps for your policy, where every Git commit triggers a policy change. Okay, and you can do pull requests and use CI/CD to check if the change even passes your tests and all of that. So GitOps is auditable. You can track authors to changes. You can have signed commits. It's immutable, so the entire history is available, and rolling back is easy, and you can use CI/CD to have tests and approve changes with PR. So how is GitOps achieved with OPAL? So first of all, the Git repo is the source of truth for the policy. Every time you push a commit, OPAL will sync it to all the agents that listen on that policy topic. And OPAL manages all of the agents by itself. So every time it will have a change, it will propagate automatically to all the agents. And it can give you back metrics and callbacks if the change was successful and why not. The fourth best practice is don't reinvent the wheel. So there's plenty of open source to build upon. So I talked a lot about policy agents, code policy agents. So we have OPA, but there's also smaller projects like also in Casbin. So you can take a look if you're interested in them as well. There's graph-based approaches like Google Zanzibar. So there's projects like OffZ SpiceDB, Auth0 OpenFGA, or Rikito. All of these will enable you to implement Google Zanzibar into your system. And finally, there's administration layers. Currently, I'm only aware of OPAL, but maybe more will emerge as open source as well. So this is your ecosystem. You can build with that. So what is Google Zanzibar? Google Zanzibar is a paper that Google did a few years ago where they modeled all their permissions based on a graph, and then they made that graph schema be flexible, and you can just define the schema of your graph. So the example that I did previously with GitHub, and like I can close issues based on a graph, you can implement easily with Google Zanzibar. So you can ask questions based on the graph schema. Okay, and this is an example of a Zanzibar schema. So this is how you typically implement Google Docs permissions with Zanzibar. So this is OffZ SpiceDB. It's the leading project in that area. So you can also have a Zanzibar solution. And OPAL can be used to sync Zanzibar systems as well. So you can just push a schema change through OPAL. You can use OPAL as an administration layer and have a policy agent and Zanzibar as well in your solution. Finally, end user experiences matter. So you want to build UIs as well. So a user management screen, an API key management screen. This is also something that you need to think about when you're building your solution. Okay, otherwise you'll get a lot of requests for R&D to have these features, because authorization features are product features, and it's something that is required to sell your product and to have good experiences for your users. So this shouldn't be an afterthought. This should be thought about when you first set out to do your project. So to summarize, decouple policy and code, use policy agents, do event-driven updates. You can do it with OPAL easily. Just you push a webhook and then everything propagates to all your agents. You want to have GitOps for policy. You want to base on the multitude of open source projects and don't reinvent the wheel. And you want to build interfaces for customers. I encourage you to join the conversation. We have a Slack channel at bit.ly/Slack. We are helping companies implement on their own. If you want, we also have permissions as a service, but you would go into the community and see we just help companies implement on their own, and it's fine. And you can implement with OPAL or without OPAL. We'll help you anyway, and we'll just discuss the best practices, learn about your use case, and try to advise you as best as we can. So we're trying to be part of the solution and advise companies how to go about their project, and where it permits Slack on bit.ly. Or if you want to go just to permit.io and go to the Slack channel. And yeah, I'm not sure we have time for questions. No. So you can find me, you can come to the stage, you can come outside. I'm available for questions if you're interested. Thank you for your time.